So my idea here is to emphasize quite a different approach to social simulation. In general, so far social simulation has taken a pure theoretical approach to understand social interaction. And behind this approach there was, and there is, the idea that artificial societies are a kind of experimental approach to understand social interaction. And it's not in the case that you find in many articles, including describing ABM, reference to the term of experiments. Well, it is true that probably there are something in common between the lab, what we do in the lab, and what we do in the computer. But here I want to emphasize that there are some differences, and these differences create the conditions for speaking about mixing these two methods. Let's try to make some, whatever. Oh, very sensitive. Right. Well, this is the homepage of my research group. But okay, this is the structure of my presentation here. So I want to emphasize the added value, the advantages of improving the realism of ABMs, and in particular to mark a difference between the ABM approach to social interaction and more conventional approaches like game theory, rational choice models, social networks models, and so on. Here the idea is that one of the main most important component about any agent-based models is the agent behavior. That's the difference between other types of modeling. We think that ABMs are good, are a good way of doing research because ABMs allow us to capture some essential component of social behavior and interaction. And another point is that this is what probably interested me when I entered in the field of social simulation, is the ontological correspondence between the model and the reality. In the sense that in the reality we see individuals interacting, okay, and this is the only way of modeling this kind, in a rich way, in an interesting way, this kind of interaction. In spite of this, 90% of social simulation models are not built upon empirically verified assumptions about human behavior. So this is the reason why I suggest to improve the realism of ABMs. And I will discuss good reasons for cross-fertilizing ABMs and laboratory experiments for improving the realism of our models. I will provide a couple of examples if I have time. And these examples will help us in drawing some insights about this relation between the lab and the ABM. In particular, I will show examples of ABMs that support or extend laboratory findings. And so the first function of ABM could be to extend, to generalize what we see in this kind of microscope, as in the lab, to more larger, more complex social systems, which is possible to replicate in the lab. One can't, invite a population of hundreds of agents in the lab. So we see some micro aspects, but we need to have something to map what we see in the lab against more complex systems. I will show some examples of lab used to test, so the vice versa, so the contrary relation, the opposite. The lab used to test some findings coming out from agent-based models. And last but not least, also examples of ABMs finding that can help or inform experimenters in designing laboratory experiments. Finally, we'll conclude with some pros and cons about this kind of research strategy because, there are advantages, but there are also critical points. In particular, as you may understand, it is a very expensive and risky research strategy because, I mean, humans in the lab sometimes behave in unpredictable ways, and this make your money disappear without results. So basically, the examples are based on two papers. One is we published in JAS 2010, and the one is under review from 1 year. But let's hope that reviewers will respond sooner or later. What is the problem? Okay, the problem is, as I said, one of the crucial advantages of ABM is that they offer a more realistic picture of human behavior and interaction in respect to conventional approaches like rational choice, game theory, and so on. But, as I suggest, the problem is that we are not taking seriously in consideration this kind of advantages, in the sense that basically we are just, at the moment, in many cases, we are just exploring alternative theoretical assumptions, which could be good, which are probably more realistic than rational choice models, but that are not empirically verified, not in many cases. And this argument is one of the most striking reasons against the ABM approach to sociology, for instance. Sociologists say, okay, just different assumptions, but no empirical foundations. And this is one of the reasons, I mean, one of the discussions that I have with sociologists skeptical about this ABM approach. So there is no close, tight integration with empirical research. And this is a problem which is extremely debated in sociology. Sociology is in general, is an empirical kind of science. So this is the reason why I insist on this, because this is my point of reference, this is my community. And there's this idea that was present in the beginning, and it was natural, about the fact that ABMs, or computer simulation, will have played a role that experiments play in physics or in other kind of sciences. I partially disagree with this in the sense that there is a tradition of experimental studies in social sciences, now probably more strong in economics, for instance, than in sociology, but I discovered when I wrote a review for a paper about experiments in sociology, I discovered very interesting contributions of sociologists arrived from the 30s, in the past centuries, of sociologists working about in a kind of experimental way. And it's good to remember that in the 70s, one of the most famous now fields of experimental science, which is that of collective action, commons, and so on, was initiated by sociologists. So the first publication was on AGS in the 70s. Then sociologists probably forgot these good first inspirations, but I think that probably is good to come back to this inspiration. So the gap between the theory and empiricism or observation is one of the more debated problems in sociological research. So this is the reason why I want to insist on this problem. Why the lab and not other kind of methods? The lab is not the only one method to collect or to gather data about human behavior and interaction. Well, why? First is that the most common empirical methods are weak, are a poor guide to collect data about interactions, because qualitative methods help you in collecting information, knowledge, data about human perception, about problems, and so on, but not about social interaction. It's very difficult to, in an empirical way, to observe social interaction with a qualitative approach. And quantitative, quantitative sociologists are not so interested in micro foundations. So this is the reason why I believe that the lab is a good means to collect data, in particular to collect very clean data, in the sense that in the lab you have under control everything, and you can, be quite confident that behavior of people is a reaction to modification of your experimental design. So you can observe what differences between moving or changing something in the lab and observing what happened in the interaction among subjects. This is good reasons, and in particular, both the lab and the ABMs are explicitly target to focus, to look at social interaction, to look at how people interact in particular kind of situations. So there is something in common seen from the origins between these two approaches. And this kind of social interaction or situation where people interact is very difficult to observe with other kind of tools. And this is the reason why there's an interesting contribution by Duffy, who is an economist, about with examples, so it's a good reference, where to find a lot of examples about the use of the lab as a kind of data generator mechanism to build empirically verified models and to observe implications of human behavior interaction in more complex systems like those which we can model in a computer and not in the reality. So this was my inspiration, and in particular, I think my reference is the eternal debate among sociologists, between sociologists, about macro and micro links. Who comes first, the individuals or the society, the relationship between individuals and structures, and so on. And these exercises of combining these two methods, I hope to show you, is also a good means to move from a kind of continuous debate, ontological debate about macro levels and micro levels, and looking at social interaction as a problem of scales rather than a problem of levels. And in the sense that the lab is a kind of microscope where you can observe what happens, how people interact in particular kind of well-controlled domains. And there is a problem of external validity. Also in the experimental literature, the lab is contested in the sense that, I mean, what you find in a lab probably doesn't correspond to what you find in the outside the lab in the reality. So there's a problem of external validity of experimental findings. The idea is to use the ABM as a kind of way, as a kind of telescope, as a kind of way to project what happened in the micro scales to a micro scale. So the idea also was an idea about, in a complex system literature, local behavior, global implications. So this is, I mean, my analogy in the sense that this is what I suggest. Also to overcome the eternal debate about macro levels of observations. Well, examples, I prepared 2 examples of my recent research, as I told you. First is, they are different, so this is the reason why I want to introduce both. First one is, we build an ABM out of a traditional game theory experiments about trust, and we played an investment game. I will describe how the game is, and we modify. We build a model based on what we found in the lab, and we modify the interaction structure starting from this kind of realistic behavior of people to understand implications of different topologies of social structures. Again, which is impossible to test in the lab. So we started from how people behave in a very well stable experiment. Investment game has been played by many different research groups, and results, findings are quite stable. So we know what happened in that kind of situation. But as you may, someone of you probably are familiar with this kind of experimental approach. But in the lab, it's usual to introduce a very simplified topology of interaction structure, which is randomly coupling randomly subjects. Also because subjects do not know each other, can't communicate, so they are randomly selected and play a game. And this is a highly unrealistic social structures. So we are used not to have this kind of experience in our life. And so we modify the social structures, introducing more realistic types of topologies. And we use the model to extend lab findings to see what could be happen if people behave in more complex social structures, impossible to test in the lab. And we draw some implications about also the literature about social networks and cooperation, which is an interesting point. At the end, we realized that our simulation findings revealed some insights that will guide us in modifying our experimental design and in testing more seriously partner selection in the lab, if possible. And the second is about reputation, and it's completely different. It's not a game theory like inspired experiment. It's more similar to an observation. So we didn't have treatments, like as in a game theory experiment. So having a baseline, modifying, having treatments to observe what happened. We build a kind of game, basically, similar to financial markets, and we observe behavior of people. So here, in the case of game theory, the experimenter wants to reduce heterogeneity of behavior, okay, just to be sure that the modification of the experimental design can explain modification of behavior of people. And there is expectation. Behind game theory, there's a rational choice, so there are expectations about theory, and you go to the lab to observe if your expectations can be confirmed or not. Here, we build an experiment to observe people interacting. And so we use ABM to also to understand what happened in a lab. And this is the reason why these two examples are completely different. Well, here we go to the first. And we know that cooperation probably has to do with the capability of agents to give rise to networks based on people who like each other. So in reality, we are not always condemned to interact with random guys. We select our partners sometimes. So we have the chance to select. And this is good in the sense that this helps us in reducing the risk of interacting with unknown partners, in particular on markets is very important. And at the same time, this provides incentives to people to signal their trustworthiness to other partners to attract a partner of interaction and to avoid isolation from a market or isolation from a social group. In the literature, there's two explanations about this importance of partner selection. First is the idea that uncertainty about unknown partners, in particular in strategic interaction, for instance, on the markets, what happened in the markets, makes long-term interaction partners look more attractive than unknown guys around there. And this is the first side. The second side is that trustworthiness and reliability can be a signal to create reputation, and so to have the chance to interact with good guys. These are the two explanations of partner selection. On the other hand, there's a research stream, quite famous in social simulation, about the role played by the continuity or persistence of interaction in creating conditions which can favor cooperation among people. Think about all Axelrod's study. But here the point is that probably what we have tried to verify is that this is not the continuity of interaction among the random continuity of interaction among people that create probably condition positive for interaction, but the capability of people to select the partners. And so, this is the point, changing the network shapes. So that's the reason why partner selection has the condition of understanding also how networks change according to the choice of individuals. So you need to have a dynamic approach to networks. So this is a point that it's very difficult to test in the lab, but it's very easy to test it in the model. So we try to verify some points in the literature, also to contest or to verify this idea of the importance of continuity of interaction between agents. The point was also that on the experimental side, experimental studies take into account very simplified and unrealistic interaction structure, like random coupling of subjects, at least in the game theory approach. And on the other, so we need to, on the experimental side, we need to investigate more seriously the role of interaction strata. And on the other hand, simulation studies investigate the role of social structure, but sometimes, and in most cases, without taking seriously, without being based seriously about experimentally verified assumptions. So we try to combine, we have tried to combine these two points. The idea was to remove mutual limitations of these two approaches, two literature, experimental and simulation, by combining these two methods. This is what our inspiration at the beginning. So let's go to the, you can, okay, ask questions when you want. Okay. This is the game, basically. It's an investment game, very simple, as I told you, played in many, many times with reasonably stable, quite stable results. And the investment game is very easy to understand. Two players are randomly selected to play one against the other, and they cover two roles. Call it play A, which is called the investor, and play B, which is called the trustee. The player A is receive an endowment, money, basically, and decide how much of this money to send to the player B without knowing, without reasons for expecting that player B return something, without information about a past behavior of player B. There is no reputation and so on, so it's very simple. And this investment is tripled by the experimenter. So this is the reason of investment. This is why we call it investment. It's tripled and sent to the player B, who receives this investment, this money, and decide how much to return to the player A. So the round ends with a communication of the earnings of the subjects. As you may understand very easily, the prediction of a rational choice implies that there is no exchange between the players, because player A doesn't have any kind of, for backward induction, doesn't have any kind of reasons to expect that the player B returns something. In all the investment games played in the lab, we know very well that rational choice predictions failed, in the sense that on average, the player A, subjects playing in A roles invest on average 40% of their endowment, 40%. And subjects playing as B returns on average slightly less, something like 35% of what they received. So the exchange takes place, and also sometimes very in positive way. We know also there are some dynamics, typical dynamics in the game. So the cooperation starts at the beginning, then stabilizes, and then declines at the end of the game as soon as the game approaches to the end. So subjects know how much rounds they are called to play. And each round, the players, so there is on average, subjects play the same number of rounds as an A or as a B. So on average, they play the same. In any round, they are randomly coupled, and one round they play as A, the second round as B, and vice versa, or B and A, and vice versa. This is we selected this also because it's quite stable results. I don't want to enter in the results of the experiment. This is not the point here. And, but the point is that what we have done was to, okay, let's try to collect the data. Let's try to investigate, to examine the data. And we have created a very simple statistical model to capture what happened in the lab with very simple parameters. Parameters for A player was one parameter that mapped the constant propensity of trust of subjects when they play as A in all the game. And the second parameter, how they reacted, how the A player reacted to the amount received by B players in the previous game. So there's one parameter which is static, basically, constant all the time, and another parameter which is we change over time according to the game, what happened. And in the case of B player, we're very simple. We have just one parameter that measures how much the B player returns depending from the amount received by the A player. So it's very simple. So each agent of our experiment was distributed in this kind of very simple equation. And we basically, okay, we discovered just by this very simple statistical models that there are some correspondence between, so subjects are coherent. So subjects who are good in invest, who took decision to invest, so to trust on B players, are the same guys who returned a high level of amount of money when they play as a B. So there are coherence about people. So trustful people are also trustworthy people. So this is the coherence, but that's not a point here. Is not here. What you have done? Basically, we have replicated exactly the experiment in an ABM. Exactly the same. Replicating the same experiments, starting from this kind of statistical model, checking if we will have lost some information by passing from the experimental data to this kind of statistical models, and we checked it, and there was no difference. And we started to modify the interaction structure. We created some simulation scenarios in the model, very simple. One experimental, like it's the same as in experimental. So each agent in that kind of scenario were randomly coupled and play each other the investment game. So one round as A, one round as B, as in experiment. So the interaction was one way. Then we modify, and we said that in the same round, the simulation round, player played in the same round, in the same role. So play both as A and both as B against other agents. So we multiply the number of interactions per round in the system. This is here. Then we assume it, we remove the condition of randomly coupling subjects. So we assume it. Let's suppose that people continue to interact with each other along the game. So this is this kind of scenario. Then we modify the structure of interaction. So we introduce the different kind of very standard topologies of social structures, small world, scale-free, and this kind of networks. But in particular, but these kind of networks were static from the beginning to the end of interaction. So there was no dynamic in this kind of network. They were static. Then we introduced dynamic networks. Let's suppose that, and we assume that each agent has a threshold happiness function. Very simple, again. If A player and I receive by the B player the same or more money than in the past interaction, I continue to interact with the same guy. Very simple. And the same as a B player is if I receive it, is I interacted with an A player investing the same or more than the past A player, I select this guy for the next round. And so this changed completely the structure of interaction, since that there is dynamic inside the structure. We tested different kind of replacement rule. In one case, broken links, the idea that when broken links means that two guys disagreed in interacting anymore. So we need to have a rule to allow the system to continue to work. The first was that broken links were replaced just for isolated agents in order not to have isolated agents in the system. Then we allow for isolated agents in the system. So let's suppose that bad guys do not find partners anymore. And so we tested this kind of assumptions. And we tested starting from randomly coupling at the beginning or starting from regular networks, different types of network topology in order to understand how this could have impacted cooperation levels in the model. And we observed some interesting things. First, we observed that just dynamic networks made a difference, so increased cooperation in respect to the experiment. And we observed also another kind of very robust results was that just when there's a chance for having isolated agents inside the system, cooperation increased. And we observed that because, that's very easy to understand, it says that good guys tend to have more links and more interaction, to be more attractive, to have higher payoffs than others. And bad guys are isolated from the system, not finding a partner anymore. And so this was some results about our simulations. This indicated the importance of partner selection. Probably in the reality, people cooperate because exactly they can select their partners. And this creates conditions also for modifying the structure of interaction. So there's an interplay between positive outcome from my interaction with another one and my network, the network I'm surrounded. So this is an example in the sense that these are types of visualization of the network. This is interesting in the sense that in this case, good guys accumulated more interaction than bad guys, and the guys at the center of the network, so having more interaction, had a higher payoff in respect to any kind of other agents. So they were attractive like leaders, and with whom all the other agents wanted to interact with. So that's interesting. This is another visualization in which there are a lot of isolated agents and good guys who are linked with each other.
So the bad guys are in the periphery?
Yeah, yeah. Bad guys are, yeah. Okay, this is not so important, but I mean, we can observe this is the most cooperative scenario, is also the one in which the average number of links per agent increased a lot in respect to the other scenarios, for the reason that I tried to explain before. So what we concluded from this exercise was that just adding dynamic to the networks made a make a real difference in respect to the experiment. And so probably it's not the structure in itself, so the continuity of interaction patterns among subjects that can create conditions positive for cooperation, but it's the isolation of bad guys at the and the possibility of good guys to interact with each other and to signal each other for new interactions. And this confirmed also some previous findings by Eguilut, I hope to spell it correctly. There's a paper in AGS 2005 about the same kind, they find the same kind of things in a simulation model without experimental foundation. Someone will say, okay, they are smarter than you. They found the same insights without playing the game and collecting money for doing experiments. That's a good point. But anyway, the idea is that agents in central position in a network have more links and so play an essential role in sustaining cooperation in a network. So there's similarity between these kind of results and our own. So out of this exercise, we derived the idea to try to come back to the lab and try to test in a small scale, because I mean that's reasonable, what happens if agents are allowed to select each other. It's very complicated, but there's someone have already done a similar experiment, so we try to probably in the future to come back to the lab and to revise our experimental design to take into account more seriously the role of partner selection. So basically, what we started from the lab, and we extend what happened in the lab in more complex social structure, assuming modifying social structure and social interaction on a scale which is impossible in the lab. So, but we started from a very well-known game theory-like experiment. So here we did something different. Here the idea was to understand the role of reputation, so exchange of information about good and bad guys among people. The role that reputation, so the circulation of the evaluation about good guys and bad guys in the system, can support the capability of economic agents to explore a very complicated and very complex and uncertain environment. So reputation as a means to enlarge the capability of exploration of agents in markets. So there was, again, there was two literature about exploration, exploitation, markets, and literature of reputation, which has something in common, but I mean, they didn't find very close connections. We tried to find this connection. And we compared with the model. So this is the lab. On the model, we replicated, as before, exactly, the experiment in a model. And we tried to compare social systems where economic agents are kind of atoms, entities, like atomized entities, so they do not share information about each other, with a system in which agents were allowed to exchange information with each other in different kind of ways. We tested exchange of information based on experience of agents, so agents capable of accumulating information about others, taking memory about others, what happened with previous partners, and so decided whether to interact with them or not. A reputation system where there information is available for all, is public and for all. And we discovered interesting things in the sense that at the beginning we were convinced that reputation, so the circulation of information in all the system about bad and good guys could have guarantee more capability, more economic performance for agents, more capability of exploring in respect to past experience-based behavior, and we discovered there was no true, so there's an interesting point I will emphasize later. And the game was more complicated than the previous one. There was a picture of the lab. We reached also popularity in a local newspaper for this experiment. So, and there was basically we call it find the best game. It was subjects were agents. They were assigned at the beginning a security with a given YAL, and they knew that outside in the environment there was a lot of securities with different YALs, and they were asked to explore the environment. So selecting a new security, investing, taking a risk of investing in discovering a new security, or exploiting the security already discovered. And there was cost for exploration and so on. It's like a kind of financial markets, basically, very rough. But the idea was to understand how the exchange of information could help people to explore this solution space. So subjects interacted, exchanged information with some automata, agents that we introduced in the system, but they were, I mean, we told to the subjects that they were interacting with each other, but it was false. So we introduced automata interacting with these guys to control, I mean, better what was the behavior. There was an initial endowment, there was final profit, final payoff. Subjects were able to very easily to calculate the final expected payoff, the final expected profit according to the securities that they have in the pocket. And so they knew very easily if they were rational to invest in exploration, asking new securities to the system, or to keep the securities they have in the pocket and exploit this kind of security. They decided what to do about security. So first decided to explore, asking randomly a new security, which could yield more or less in respect to what already discovered. There was a decreasing function, so the more you keep your this security already discovered, the less they profit over time. Also. And so there was incentive to explore. There was an option of exploitation, keeping already discovered security and not asking a new one to the system. And there was the possibility of follow other ins, which was the social information, our idea. So the fact that people say, okay, believe me, there's a security out there which yields more than what you expected that it yields. So there was this kind of, they were bombarded by ins, a suggestion by other agents about, yeah, this suggestion could, this is a communication part. This suggestion, these ins could be right, could be wrong, could communicate lower and higher yields in respect to the reality, and so on. So we biased a lot this kind of communication between people. So they were asked to discover, decide what to do about their yields, their securities, and they were asked to communicate with others, okay, in fixed way. So these were 4 options. So they could send messages about this kind of 4 kind of messages to others. And okay, basically we do it. There's a paper on JAS. You can read it for details. But anyway, basically we discovered what we have done was to do a statistical analysis out of the experimental results, and we discovered very interesting things. I hope so. You discover that people who trust others are the ones who tend to explore more. and the one who tends to not to lie about the true yields of the security, so they communicate real yields about security, and they tend to reciprocate, so to send wrong ints to subjects who sent wrong ints in turn in the past. So reciprocate also about information. If you have sent a wrong int, I tend to send you in turn a wrong int as well. And players who tend to lie, so who tend to communicate false, wrong ints, were the same who didn't trust each others and tend to exploit given solution. This was the patterns that we observed in the lab. Yeah, we replicated the experiment. This is a simulation. This is final profit, endowment, and exploration of subjects, so very similar. The only difference is because of random aspect, which is not so crucial to discuss here, but they are very close, the behavior of the system in the two conditions. And then, as before, we started to modify some parameters. We increase the number of agents. We allow agents to interact directly by randomly coupling agent. We increase the variability of yields in a system with respect to the experiment. We introduce a scarcity of resource more than in experiments, and these are the most important parameters of the simulation. So we modify some parameters, which is easy to be modified in the model. We create different simulation scenarios in which we also explored what would have happened if subjects would have followed specific kind of strategies. So we create a scenario where we suppose that agents just exploited. Agents, the second, just explored. So we observe trade-off between exploration and exploitation, which is very easy to understand. We suppose that what happened if subjects would have always listened, always followed hints. This is a listen always. And then, this is the new layer, we introduced a more complicated process of evaluation of other trustworthiness by allowing agent to, without allowing agent to develop memories about other agents. And we assumed a positive, in one scenario, a positive attitude toward others. So I tend to trust others at the first time. Then I observe if they cheat me, if they lie. Or negative attitude, so I don't trust. So I have to observe behavior of others before to interact with them. But this is individually, a kind of individually based strategy of accumulating information about others without sharing anything about the information. Then we introduce the possibility of sharing, so reputation in our meaning, the possibility of sharing this kind of information. So when an agent discovers that another guy is a bad guy, okay, this information is public for all in the system. And we observed an interesting point in the sense here, where agents followed individual strategies for finding information, for classifying agents, and so on. This makes a system. This is a very how to say? It takes a lot of time because agents should have to interact with each other, putting the evaluating bad or good guy, keeping track of memory about each one with whom they interacted, bad or good guy, and so the evaluation of agents in respect to each other takes a lot of time. Okay, here it's very easy. The first round there is already some reputational information. Okay, because this information is made public for all. And this is more fast in accumulating information about others. This require more time. And the results are are interested in the sense that we discovered that negative attitude towards others in the first encounter is good for profit. So agents were more capable of accumulating profits if they were negative, when they had negative attitude in respect to others, so skeptic about other trustworthiness. But there was no difference, for instance, in a capability of exploration in the system. So they were quite similar, the two dynamics, where there are difference in a profit, negative and positive. But I mean, this is just a detail. And we discovered, for instance, an interesting pattern in the sense that list and always int, doesn't matter if wrong or right, was not so bad in respect for the final profit. So, for instance, this list and always is very close as performance as individual as a individual with the negative attitude towards others. So we discovered something, but I don't think it's crucial here. I want to just more to emphasize the methodological aspects. We discovered, for instance, that both in the case of individual strategy for collecting information about others and reputation systems, both these two conditions were good in reducing the numbers of lemons, so the numbers of wrong ints in the system, with some differences but not so crucial. So here we counted the number of false ints per round in the system, so the number of lemons. And they increased at the beginning, but then the system, both in the condition of individual strategy of collecting information and so on, and in reputation were about the same. So reputation didn't increase so much the capability of the system in reducing the false ints or lemons in the system in respect to the individual strategy, even if it was faster than as a mechanism, it was faster to spread information through reputation, public information, than to individual based strategies. But I mean, this is, I don't know if you want to have more information about these results, you can maybe ask in a discussion. I want just to emphasize that, okay, next step, when we have time, will be to explore more complicated, more sophisticated reputation mechanisms in respect to the present. I mean, so we want to enrich this kind of reputation mechanism. Probably is too much easy, too much crude as a kind of reputation mechanism to make a difference in respect to other mechanisms. But this is for future research. Well, basically, what we have done so the two examples are different. I mean, I hope that you have a clear intuition about the differences between these two types of exercise. So, well-established game theory framework experiments, and we modified the structure. We used the lab findings, and we modify the interaction structure to observe implications of this modification for behavior of the system. In this case, we started from more an observation than an experiment, okay, where the strategy was to explore the highest possible heterogeneity of behavior of people instead of reducing, as in game theory experiments. Okay, there was no treatment. There was no this idea of baseline treatment as in game theory experiments. And in that case, we used ABM to investigate what happened in the lab, than to derive implications of what happened in the lab for in case of larger or complex systems than in the first example. But anyway, here's the strategy that it seemed that we want to explore also in the future. Crucial is having data coming from the lab that informs the ABM, and data coming out from the simulation findings that probably, hopefully, can inform new design of the lab. Everything is based on the idea of evidence. Try to collect evidence on the two sides on the same time. And this is a way to also to defend the idea of a cross-fertilization between these two methods in a best case. Well, let me conclude in a few minutes about strengths and weaknesses of these types of exercise and these types of versus strategies. Okay, I mean, positive things is that in this case, we can be in a position of combining some theoretical side and some observational or empirical side. And so the models are guided more by evidence, by observation, by empirical evidence than by speculation or by theories. And this is good, in my view, for the reasons that I try to explain. And another positive thing is, as I told you, to approach this eternal debate about micro-macro links in a kind of secularizing this debate, by understanding that probably is probably it's more easy, at least, to approach this issue in terms of scales, as I tried to explain. So what happened in the lab, micro level, as in the microscope, and what is the implication of this for macro systems. And I mean, I'm not ambitious to have solved the problem of the micro-macro link in the social sciences, but this is an interesting idea. Looking at the scales instead of levels probably is good to try it. At least very easy in social simulation to reframe this problem as a problem of scales in respect of levels. And we have, in this kind of other hypothesis, things that we can reduce the problem of external validity of experiments, because one of the problems is that what you see in the lab probably doesn't correspond to what you see in reality in more complex, more larger systems. With ABM, you can map these two sides, and this can also allow us to probably also to try to falsify some results in these two exercises. So it's easy probably to falsify something in the lab. But if you falsify something in the lab and also in the model, probably it's good, in my view. Yeah, what are the weaknesses? At least the most what I see the weaknesses, and this type of research is very time, money, labor consuming. I mean, if there is someone of you having some experience in designing and performing an experiment in the lab, you can understand what I mean, and then again you have not just to go to the lab, also to build a model according to what happened in the lab, to set up parameters according to what happened in the lab, to rebuild in the model the same interaction situation and environment that was present in the lab. So it's consuming. It's also risky because you need a lab, you need facilities, and you need money, and as I told you, human escape predictions in the lab. There's a problem. It's a problem of balkanization. In particular, this is a problem of experimental studies. It's an incredible thing that research groups studying the same kind of, using the same kind of game in the lab, playing the same kind of game, have to replay the game many times because, I mean, research groups don't share data. So it's incredible. It's a waste of money. So when I want to play an investment game, I can't use the data of my colleagues who played the investment game, the same one, the same kind of baseline, the same kind of treatment for 10, 20 times. So I have to redone everything all the time. This is completely crazy. And in this case, simulation can, we are very sensitive to the idea of sharing models, of replicating models, and so on. So probably this is that's a problem that is very crucial in experimental literature, and that we have to try to solve in some kind of way. Another problem is that there are no standard way. There are no standards which to rely on. So, I mean, it's a handcraft research strategy, and which all the pros and all the cons of this. And anyway, this problem of external validity is present also in simulation models, and also in experimentally based simulation model. It's just a first step towards progress, but not a definitive progress, as you may understand. Probably there are other weaknesses that you want to discuss with me. Okay, this is the end. As I understood from lunch with Nigel, it's important to advertise new books. So you find some some of this idea in a book that I try to finish. If I don't spend too much time in summer schools. No, I'm joking. And probably the beginning of the next year that will be published by Wiley Blackwell, and I used a lot of this idea in this book. So if you want to, there's also a web page of support where we'll find a lot of model codes and so on. You will find it in the book, but you can contact me. And no free copies. And so thank you very much. So.